A telescope consists of two converging lenses. When in normal adjustment so that the final image of a distant object is formed at infinity, the lenses are 450 mm apart and the angle of magnification is 8. What are the focal lengths of the two lenses? Is the image erect or inverted? This has been done in the notes, but I will just show you how it is done. Just draw a simple diagram like this. This is your objective. So the ray of light comes from infinity. And the intermediate image is formed here. So this is the ray of light coming from infinity to the objective. So alpha is here. This distance is FO. And then the eyepiece is placed such that the intermediate image is formed at the focus of your eyepiece, so that the final image, which by the way will be an inverted image, is formed at infinity. So this is your beta. This is H and this is FE. So the lens separation, let's read the question again. The lens separation is 450 mm and the angular magnification is 8. So we have FO plus FE is 450 and FO by FE, which is the expression for magnification, is 8. So we have FO is 8 FE. So 8 FE plus FE is equal to 450. So when you do the calculation, we have 9 FE is equal to 450. So FO is 400. So this is your focal length for the eyepiece and the focal length for the objective. And see how simple diagram it suffices to do whenever you have to solve mathematical numerical problems like this. Let's now look at the next question. Slightly different question. A telescope consists of two thin converging lenses of focal length 100 centimeters and 10 centimeters respectively. It is used to view an object 2000 centimeters away from the objective. What is the separation of the lenses if the final image is 25 centimeters from the eye lens? Determine the magnifying power for an observer whose eye is close to the eyepiece. So here focal length of the objective is 100, of the eyepiece is 10, object is 2000 centimeters away, and the final image is at 25 centimeters. So slightly different diagram, because here the object is not at infinity but the object distance is given. So we can just do it like this similar diagram. So we have got the objective here. So say the object is here. So again the intermediate image will be formed like this here. Then we have the eyepiece, and the eyepiece will form the final image. At the near point. So just labeling, this is UO, object distance for the objective. This is alpha, this is also alpha, this is VO. Earlier, when the final object was at infinity, the image was formed at the focus of the objective, but that is when the final image, the object was at infinity. But here, because the object distance is finite, the image is formed at V0, and this one is UE, and this distance is D. The VE is, and this is beta, and this is HI, this is height of the object, and this is the intermediate image H. So they have asked us to find the magnification and the separation of the lenses. So let's see the separation. VO plus UE is the separation. Now we can, so we need u0 and we need v0 and ue. So for objective, 1 upon f is 1 upon v minus 1 upon u. As far as the objective is concerned, it's got a focal length of 100. The image distance we have to find. The object distance is 2000, and because it's to the left, we put a negative sign. So as far as the v of the objective is concerned, let's see what we have solved. We have found that v0 is 105.3. So v0 is come to be 105.3 centimeters. And let's say for the eyepiece, okay, in 1 upon f is 1 upon v minus 1 by u. The focal length of the eyepiece was 10. The image was formed at the near point, which is 25. But because you are measuring to the left, it's minus uo. So when you do this one, our uo calculation is coming to be 10. The UE calculation is coming to be 7.1 centimeters. So this is for the eyepiece, so it is UE, not UO. So 7.14 centimeters. So the separation is 105.3 plus 7.14. That's about 112.4 centimeters. Now magnification is beta by alpha. So I'll just show you. Beta is here. So beta is h upon ue. So we write beta is h upon ue. And alpha is equal to, and once again you can check here, alpha is taking h upon v0. So alpha is h upon v0. So magnification is v0 by ue. So we have found v0 to be 105.3 and we found ue to be 7.14. So when you do the calculation, which we have already done in our problem, we find it is 15.8. So really there's no need for the formula, provided we can draw the ray diagram, and it's generally drawn like this. See, we've got the objective coming from infinity is focused here, and then depending on, so suppose if this is FO and this is FE, then this goes to infinity. But say we've got something coming from infinity, ray of light coming from infinity, so this is FO. But here if it is not FE but UE, then final image is formed at distance d. And in the third case, sometimes the object distance will be given, so in which case your intermediate image is here, and the final image will either be at infinity if this is FE, this is of course VO and this is UO, or the final image could be here if this is, when this is D. So this is UO, this is VO and this is UE, not FE. When it is FE, it is at infinity, but when it is some other distance within the focus, then you will have a virtual magnified image here. And in the next class, in the next question, so one of those questions, the final image is being received on a screen, which means that the final image is a real image. So what that will be, we'll do it when we solve that particular problem.